Hello everyone, my name is Yuhan. I'm currently a third-year PhD student in the College of Information Studies at the University of Maryland. Today I'll be presenting this work, TandemTrack, Shaping Consistent Exercise Experience by Complementing a Mobile App with a Smart Speaker. In recent years, the smart speaker market is growing rapidly, especially with the introduction of Amazon Echo and Google Home. At the same time, the market of third-party voice applications for smart speakers is expanding. If you go to the Amazon Alexa skill marketplace, there are tons of skills supporting different activities. Here we also see a category of health and fitness. Although this is not the most popular one, there are already over 2,000 skills listed there. So in this study, we're interested in the context of supporting in-home exercise and wondering how does a smart speaker complement a mobile fitness app. We had some assumptions. First, the hands-free interaction of smart speaker can lower data capture burden, especially during exercise process. Second, the voice prompt sent from the smart speaker can be more attentive in the home environment when people don't carry their phone with them all the time. Third, because we have to charge the device in a specific place, the lack of mobility can force a consistent exercise location, which can be helpful from the habit creation perspective. But an obvious drawback of smart speaker is the limited visual elements it has, which limited the type of exercise feedback that they can provide. While on the other hand, the mobile phone has rich visual elements, but the interaction with it is not hands-free. So we see both pros and cons of these two modalities, and in the study, and rather than competing one against each other, we combine these two modalities together by asking this research question: how does a smart speaker complement a mobile fitness app in supporting consistent exercise? So to answer the research question, we designed TandemTrack, a multimodal exercise system consisting of a mobile app and an Amazon Alexa skill, to situate people to experience interacting with both the mobile app and the smart speaker in a simple exercise context. The two modalities support the same key features, including an exercise regimen that alternates between sit-up and push-ups, data capture, exercise feedback, and daily reminder. In addition, the two modalities share the same database, so no matter which device you use to exercise, the data is synchronized on both. Now I'm going to show some video clips to illustrate how the skill and the app work.
Here's your reminder. Time to exercise.
Alexa, open TandemTrack.
Hi, Yuhan. This is your day 22. Your workout today is push-ups. You can say start trainer to get started.
Start trainer.
Starting trainer. Set 1 will begin in 3, 2, 1. Start.
So here the user receives a reminder, invoke the skill and use the command start trainer to start exercise. The entire exercise session lasts 3 minutes and 30 seconds with 3 exercise sets and 2 breaks in between. So moving on.
How many push-ups did you complete in set 1?
23.
You've completed 23 push-ups. Set 2 will begin in 60 seconds.
So by the end of each set, the skill will ask the user how many push-up or sit-up they complete and take their voice response as input. When the user is done with all 3 sets, the skill will record their exercise information and give a confirmation message like this.
How many push-ups did you complete in set 3?
17.
Today's training is complete. You have done a total of 58 push-ups. Great job.
So this is the exercise flow on the skill. On the mobile phone, the flow is similar. First, the user receives a reminder, which is a mobile notification. They go to the app, go to the exercise page, and start training by clicking a button. The process is similar. They have to go through several rounds to input their data. The only difference is that they have to type the repetitions manually like this. When the session is ended, they will be returned back to the main interface. So now let's look at the exercise feedback. On the Alexa skill, people can ask general questions such as how's my workout, or more specific questions like how many sit-ups did I do yesterday. So here's an example. What is my streak?
Your longest streak is 15, from December 6th to December 20th.
How many push-ups did I do yesterday?
December 21st, your workout was sit-ups, and you did 37 sit-ups.
Okay. So on the mobile phone, the exercise feedback is shown in a set of visualizations, including the daily exercise details on the top, a summary of streaks and workouts in the middle, and in the bottom there's an exercise overview. By swiping right, there are two bar charts showing a sit-up progress and the push-up progress. With TandemTrack, we did a between-subject study by having 22 participants exercise for 4 weeks. Half of the participants were assigned to only use the mobile app, which we referred as M group, and the other half participants were assigned to use both the app and the Alexa skill in the way they like, and we refer this group as MA group. Throughout the 4-week study, we learned a lot of interesting findings, but due to the interest of time, I'm not going to cover everything. If you're interested in knowing more, you're welcome to read our paper. So for the exercise adherence, we use the 3 variables, including the total number of days people complete exercise, their longest streak, and average streak to characterize the exercise adherence. However, we didn't find any significant difference between the two groups. Because of the no significant difference, we further look at MA participants and how they used the exercise regimen and data capture on the app and the skill. We first look at how many exercise sessions they complete on the app and the skill, and the average data showed us that there are slightly more sessions on the app but didn't tell us more information. But if we expand the individual participants' data, we will notice that everyone is actually using the skill and the app in a very different way. There are 2 participants never interacted with the skill at all. There are 5 participants use the skill more often than the app, and 4 participants use the app more often than the skill. So why is that, and what made the difference between individuals? In a debriefing interview, we asked the participants to describe their choice between the app and the skill to exercise in different contexts. The first thing came out is their personal preference. For those who prefer using the skill, they mentioned that they like the skill especially for the push-up, because it involves intensive use of their hand, and it's a bit challenging to type the repetitions on the mobile phone, and the voice interaction can make it easier. For some of our participants, they are fitness fanatics who already know very well how to properly do sit-up and push-ups. So the visual interface is not that helpful in this case, but the voice interface can actually help them reduce distraction and improve their performance. As I just mentioned, there are 2 participants never interact with the skill. They explained that during the interview that they don't feel comfortable interacting with a personified machine, and the interaction with it is not intuitive. Second, the proximity to the echo device and the people's exercise space also affect their choice. When they were close by, they will use the skill, especially when they receive the reminders. They can just go ahead to get started. But if a participant is not enough close, they have to turn to their mobile app. And this is not just about distance, it's also about the exercise space and structure of living environment. As our participant M18 explained that she rearranged her room during this study, she can still get close to the device, but she just couldn't find a space that big enough for her to do exercise near the device. Another strong factor we found is social influence. For those who live with others, they sometimes worry about interrupting their roommates, so they only use the skill whenever there are no one there. And some participants consider exercise is a private activity, and they don't want to speak out loud to let others know that they are doing this exercise. Family dynamics is another interesting thing. So this participant MA3 explained that ever since my 4-year-old son found he could ask Alexa knock-knock jokes, he kept shouting at it every day, and my husband got really annoyed, so he unplugged the device a couple of times. So this is another big difference between the smart speaker and the mobile phone. As we put the smart speaker in a household, how others interact with it will also affect the primary user's preference. So after talking about the exercise regimen and data capture, let's move on to the findings regarding exercise feedback. So for the mobile app's visual feedback, we found that M participants spend more time reviewing the feedback on the app than MA participants. This is because M participants are already using the app to exercise. Reviewing the app is very easy to tag on for them to look at the visualizations before and after exercise. But for MA group participants, they sometimes forget about the app, especially when they are exercising using the skill. Reviewing the visual feedback just didn't prompt them. For the skills voice feedback, the results is a bit disappointing because only 5 hours in total were logged throughout 4 weeks. Participants explained that they are already happy with what's there with the visual feedback and they didn't feel necessary to ask questions from Alexa. They also forget the voice command to use, although we had asked them to practice several times during a pre-study tutorial which we held before the study. Some participants pointed out the voice feedback lends support for data exploration. Even if they would remember the voice commands, sometimes they don't know where to get started. So based on the findings, we learned a lot of valuable lessons. The most important one is that simply by complementing a mobile app with a smart speaker does not necessarily increase the exercise adherence, but many opportunities exist there in enriching people's exercise experience. The potential value of the hands-free interaction can help us extend TandemTrack to support different exercises beyond sit-ups and push-ups, such as plank, body pump, which involve intensive use of hand. In addition, based on individuals' exercise skill level, their performance can be optimized by tailoring the primary interface. For those who are exercise novices, they may focus on the visual interface for correct postures and pace. For those who are exercise experts, they may want to focusing on the voice interface to reduce distraction. As we found from the study that the voice feedback was rarely used, which makes sense because by nature the voice is not that attentive compared with vision. To improve that, we can coordinate the voice and the visual in delivering feedback. For example, prompting relevant visual feedback when people are asking questions from Alexa, and provide more details in the prompts so that can support data exploration. In addition, we can leverage on the critical reflection moment, which is before and after exercise. The skill can prompt people with some interesting exercise data or learning what type of data they are interested in by learning their usage pattern on the mobile phone. In this case, they would be more proactive rather than waiting for the people to initiate a query. Lastly, although we see TandemTrack as a multimodal system, the current version is not ideal due to limited support for third-party skills and commonly occurring voice recognition errors. An important next step for us is to enhance the synergy between the app and the skill. We can enable people to control their exercise progress on either device during exercise. For example, if a person is exercising using the skill, they should also be able to control to pause the session to enter their data from the phone. Another thing is to send in proximity-based reminders, so when people are not close to the Echo device, a mobile notification can be prompted from their mobile phone. With that, we will be able to build a more integrated and multimodal exercise experience. So that's basically all about the presentation today, and thank you for your attention.